Okay, Danny, I think I'm going to go ahead and start. Once I start running through the introduction, I anticipate some of the attendees to join us, as this is a crucial transition period between meetings. So, ladies and gentlemen, a very good afternoon and welcome to this month's East 101 webinar. This is our 11th talk under the series, and it's a pleasure having all of you here with us this afternoon. Before we move on, allow me to introduce myself. My name is Avinash, and I'm the Business Development Manager at East 101, and I'll be your moderator this afternoon. Before we start, I'd just like to lay some ground rules to ensure we run the session as smooth as possible. The first one here is recommended that all of you mute yourselves, as this helps us avoid any unwanted interferences. The second one is to suggest you to turn our camera off. This helps us save a lot of bandwidth in case the connection goes wrong. And the third thing is we recommend you to pin the presenter, in this case, Danny, as the main screen. This will allow you to see his presentation deck in an enlarged mode, as well as you can enable fit to frame, because at times Teams doesn't actually expand till the ends of your screen. So you can do that by clicking on the presenter icon and then selecting fit to frame. Okay, that's about all for the ground rules. Now let us jump into the session. So today we have a very interesting topic where we'll be diving deep back down to the roots of process design, and we'll be discussing how actually the work and the investments that we have made during the design of an asset can be leveraged to improve the operations of the asset by developing operator training simulators and ultimately reaching the end goal of developing a digital twin. And we call this a sustainable approach, and is regarded as life cycle modeling. And today we have Daniel Martínez from Inprocess, who's the sales director and strategic account manager, to share how Inprocess has been deploying the solutions for clients all around the globe. So I'd like to take this opportunity to thank Dani for joining us all the way from Barcelona. I hope it's a bright, sunny day for you there.
Yeah, okay. It's fine. It's a sunny day. Thank you. Thank you very much, Avinas, for
Yeah, it's exciting to see the numbers going up. I hope all those here enjoy the session. So without further ado, let's get started. Before I pass the floor over to Dani, I'd just like to run a quick introduction of East 101 and the events on the webinars that we've been organizing. So East 101, we're a specialty consulting company founded in year 2003 by engineer Rafael Elias. So over the last 18 years, what we've been doing is that we've been delivering advanced process engineering and flow assurance consultancy services to the oil and gas industry. So we cover the entire oil and gas value chain from upstream, midstream to downstream. So our offices is actually based in Kuala Lumpur. To be exact, we are in Shah Alam, very close by to the Stadium Shah Alam, Stadium Lawati, if you're familiar with this area. So what we do here is we do all our engineering studies and also work on some software development. Apart from our presence here in Kuala Lumpur, we also have partners all around the globe. In Barcelona, we have our partners Inprocess, with Danny is joining us. So what we do with Inprocess is we work on life cycle modeling initiatives as well as operator training simulators. So apart from that, we have sales offices in London, Brisbane, and Houston. So that's a brief summary of the company and what we've been doing. And this here is to give you a very high-level overview of what we do in specific areas. So our core business has always been transient simulation-based engineering services. This has been our bread and butter for the past 18 years. So you can broadly classify the things that we do here as operability and controllability studies, as well as pressure protection studies. Another area that we look at is flow assurance. This is primarily running case studies for pipeline hydraulic scenarios. And what we do with the results is that we develop operation strategies, wax management strategies, as well as liquid management strategies. Another area that we recently started taking a look into is operational assistance. This is actually leveraging a combination of simulation technology as well as other technologies to deliver performance monitoring applications as well as operator training simulators. And we also are working on a lot of custom software development, and we are putting together a new simulator tool for flow assurance and drilling applications. So that summarizes the operational assistance area. Apart from all our services, we do provide a lot of training. We have three curated training courses. which revolves around process simulation technology, steady state and dynamic courses, as well as a new course that we have incorporated into our portfolio is machine learning and AI. So we have been running this introductory machine learning and AI courses for the local university and some of the national engineering and oil and gas companies. So that, I believe, should provide you an overview of what we specifically do for the oil and gas industry. The next slide here summarizes a partial list of our clients. These are some of our selected clients. If you notice, we have worked with the entire oil and gas supply chain, starting from operators, engineering companies, as well as FPSO companies. So if you have any questions with regards to the company or services, feel free to reach out to me. I'm Avinash, or you can reach out to my colleague Mugzen at the numbers given. If you do, or else you can also reach out to us via email, sales@east11.com, and feel free to visit our website for all the webinar archive that we have conducted so far. Okay, that's a brief overview of our company. Now let me just talk to you about the East 11 webinar series. So this is our 11th. We have completed roughly 10 webinars before, and we focused on 5 main areas. General process engineering. We also look at process design, downstream and refining, monitoring and surveillance, and analytics and AI. So today is an interesting hybrid topic that's going to be an extension to process design and operational excellence. So we do this on a monthly basis, and it usually happens on the second Wednesday of every month. This month is an exception because we couldn't get Danny. Danny was really busy, so we had to postpone our session to the third Wednesday of the month. And we usually run the sessions from 4 to 5 p.m. Malaysia time. So keep a lookout for the upcoming events on LinkedIn, and you can also visit our website for our upcoming webinars. So before I introduce Danny and pass the floor to him, I'll suggest that you drop your questions in the chat box. What's going to happen is that at the end of the session, I'm going to pick some of the questions and ask Danny. And if you feel comfortable, you can also unmute yourselves and ask your questions to Danny directly. So, yep, let me just briefly introduce Danny here. Danny has a bachelor's in mechanical engineering with close to 18 years of experience in sales and business development. He has also covered the entire spectrum from oil and gas industry, refinery, and petrochemical industries. So before his journey with Inprocess, he used to work with some final control elements and plant instrumentation solutions company. He joined Inprocess roughly 7 years ago, and he focuses on specialized simulation-based solution. As a sales director and account manager for the Asia Pacific and Latin America region, as well as Spain, he has contributed a lot of his time and energy in definition of scope of works and selling the integrated vision of the LifeCycle-Modelling OTS to many clients all around the globe. So with that experience, I'll like to invite Danny to share his insights with us here today. Thank you, Danny. Over to you.
Thank you very much, Avinash, for the introduction, and thank you very much for having the opportunity to share this session, this webinar with you, with this one-on-one today, with this broader audience. Please let me share my screen and confirm me, please, when you are capable to see.
All clear.
All clear. Okay, thank you. Okay, thank you very much. So today, what we are going to propose is this agenda. Just to not to take too much time, I would like also to provide to you a little bit of introduction about Inprocess and our commercial relationship partnership with this one in Malaysia and the Asia Pacific region, and of course going directly through the topic. Talking about project and simulation lifecycle, the simulation lifecycle workflow, and how it's linked with the initiative of lifecycle OTS approach and the different areas, phases, and added value and insights that we could provide to companies like you. We are talking about operating companies, about engineering firms, along a project execution and later phases of operational and maintenance, and how our services and our added value can bring not only benefits in terms of technical insights and support, but also economical benefits along the project execution, right? And finally, we will share reference and public contributions and reference lists that we have already deployed. Later on, I will explain why you here can see a picture of an instance and an FPSO, right? So following the agenda, I'm very in brief. Inprocess, it's important to mention that we are an independent company from any technology regarding process simulation and regarding ICSS. That means that we, as Inprocess, are performing simulation services by using the most proper and most adequate simulation technology, depending on the kind of study, depending on the kind of project that we are going to execute. So we do have a full expertise by using softwares so well known like Aspen HYSYS in dynamics, like Honeywell Unisim, like Schlumberger Symmetry, like Schlumberger Olga, or many other kind of technologies, and the ability to link and to connect with the most popular ICSS technologies like Emerson's, Yokogawa's, Honeywell, Siemens, or any other. It's important to mention that same as our partner, as is 101, our core business is process simulation services. That means that we are a pool of simulation engineers focused and specialized on just deploying projects around process simulation services. That means supporting engineering companies, supporting operating companies, supporting technology providers, supporting equipment manufacturers along the different life cycle of a project or a plant design, right? And again, same as is 101, we do have the capabilities not only to deploy projects, but also to train. We have the lecturing capabilities to train engineers and to train operators, control room operators and field operators in how to best perform in their plants around process simulation technologies. So just a few numbers. Inprocess was a company that was founded in 2006 by a team former from the Hyprotech and later on Aspentech. So we do have a very long track by using simulation technologies like Aspen HYSYS, in instance. But again, we are right now capable to perform services around many technologies. With global presence in 45 countries, we have deployed projects worldwide with more than 400 projects regarding process simulation. And of course, it's important to mention that we are a very big team located in Barcelona. We are right now 65 simulation engineers in Barcelona, focused again in providing simulation services. Simulation services about process, that means chemical engineers, but of course, optimization and control engineers and data scientists to be able to deploy more complex solutions than just studies and later on OTSs, right? So one of the key facts today, we are going to talk in detail about such kind of approach, which is called life cycle modeling. Life cycle modeling means how to meet the needs that engineering firms and operating companies have along a project execution in a green field, like a straight line along the different phases that we need to cover along a green field. And also we are further explain how this later on close the circle, and later on, once you are in operations and maintenance, we do have this closed loop to take advantage of this kind of strategy when it's applied in a plant. And the reason why we mention here and we put here the picture of an FPSO is because this philosophy, this life cycle modeling philosophy, we have already applied in many different industries, not only oil and gas and not only FPSOs, but FPSOs is a very clear example because it's a clear example of a complex plant, which is really constructed by a mix of different packages. And so that companies like you, companies like engineering, and companies like operating companies need to match many different packages that later on are being governed by local PLCs, by an ICSS, a global ICSS, but finally is composed by a very spread mix of different packages that conforms the top side and the subsea of a facility like this. This is the example of why we are using and how we will address all these phases with the clear example of on an FPSO. But it's not only the question of how to approach a project by doing this philosophy. What we also do is, of course, studies in steady state, in dynamic, flow assurance, integrated flare system analysis, modeling of utility networks and online models, and operation and maintenance support from upstream, midstream, and downstream. Of course, we provide training also to engineers and to control room operators, and we have developed our own software, being able not only to provide studies, not only to perform some project, but to complete an OTS. It's needed a full set of technology. It's not only building models, it's not only having the knowledge of how to interact with the ICSS vendor, but you need to create a full environment to link the dynamic models with the ICSS and to provide all the training features and functionalities that you are expecting from an instructor point of view, right? And so this is the kind of software that we have been able to provide for specific OTS, high fidelity OTS, generic OTS, and any other applications. So not to delay the point, I mentioned to you that we are gonna address today's season about lifecycle modeling OTS, taking as an example an FPSO. And one of the things that we need to analyze is what could go wrong in instance in an FPSO. When we are talking about an FPSO, and we are talking in particular about an instance, a greenfield project, we need to think about the different phases that we need to cover along project execution, and how companies like EPCs and operating companies are asking Inprocess and asking is 101 to perform different studies along project execution. So what it's important to mention is that first thing that we address is try to solve the different process design that may appear in a project like this, or in a facility, in a processing facility like this, right? And first thing that we address is the kind of process design studies that we deploy to address different issues that may appear regarding the process design. That means recycle valves design, hot gas bypass requirement, compressor driver constraints, gas turbines constraints, set points consistency, trip value settings, right? So the other kind of upsets that we may face, one of them are related process design. The other kind of upsets that we may find along the project execution are related to operation procedures, control narrative, and ICSS codification, right? And the third block of issues that we may face are regarding human error. So one of the first things that we need to think about is how to address the different impacts that may have an issue in process design, an issue regarding operational procedures, control narrative, and ICSS codification, and what is the impact in the human errors, right? And how them impact in a long, in a short, or in a long term, depending on when do we face this, and how Inprocess and the IS 101 are able to address all these issues along the project execution. And this is the reason why we implement this life cycle OTS modeling. It's the only way to address all this with a unique partner, a confident partner that has the ability and the knowledge to start working with the process design, engineering and validation, and move along all the project execution to cover all these stages, right, until the OTS, right? So we'll talk later on this by doing this chart. This chart shows how finally process simulation uh, impacts, or how process simulation would be applied along all a greenfield project, right? So what it's already known is that we do have the simulation life cycle that can be applied in the different stages that you are facing along a project, right? From the feasibility studies until operations and support, of course, and which is the plant life cycle or the project life cycle in terms of conceptual, fit, EPC, and later on phases of commissioning and startup and operational and maintenance. Depending on the phase, on the stage that we are, of course, process simulation can bring different advantages, right? First thing that we address is the design verification for the conceptual. Uh, second, second step or second item that we address with process simulation is the process analysis itself, helping in the equipment selection, support the HACCPs, uh, doing a complete package integration and the analysis not only of the standalone packages like compressors, like GTs, like separators, etc., but it's the integration of the different packages to complete, the top side of an FPSO. In instance, how do we test and how do we do all the PAD control tuning, not only the different packages with the local PLCs, but also how they need to be handled and controlled under the complete DCS. We complete and we deploy the OTS training and the operation support. So along the project execution from conceptual till the completion of the EPC and commissioning startup, what we are receiving from your side is different packages of information that depends, of course, on the availability of this information along the project execution. Of course, when we start supporting the design verification and the process analysis, and in here we are closely working with process team, we need to talk in the same language than them, right? And so that we use the same process simulation technology than your process team uses. If you are a Aspen HYSYS user, we will support you with Aspen HYSYS Dynamics. If you are a Honeywell Unisim user from your process department team, we will use that technology. So again, we are open to support talking the same language than you and evolving that models, adding more details into the model, being able to complete the different expectations that we do have along this project execution, and including the additional detail that it's needed to cover the different findings that we need to address along the project. So as far as the information makes available, we start working unit by unit and package by package. And of course, as long as the facility is more complex, as long as we are doing the integration of the different packages, we are linking the different packages to being able to first support all the design verification and process analysis of the different units standalone, and later on how to link all of them to build a complete flow sheet of the entire topside FPSO or complete plant if we are talking about a refinery unit, petrochem complex, or whatever. Fine. So main philosophy here is that from your point of view, you need to rely on a trustable company that it's able and has a long track record, not only in providing studies, not only in providing OTS, but having same company who is able to reuse the models during all the life cycle of the project and the plant building, right? That allows a more efficient and horizontal workflow. That means we are evolving that information. What we are doing is that finally retaining the expertise and the knowledge that we get from the early involvement in a project, not only for process team, but also to be reused later on for optimization and control and operations and production. Because it's true that in many projects we have been involved in the early stages of the project, and later on operations may ask for the same things that we address with process, because there is a lack of this retainment of expertise and knowledge. From your side, having a unique partner allows you to have all this capability to get and to retain what we first saw during the studies, to be later on also used and in value from your operation team, right? So operations use high fidelity models that we have been created during all the studies phases to do many different things and many different findings, like is ICSS test best, control and process optimizations, control tuning, sorry, the bollering neck studies, incident review, digital twins, etc. So with that strategy, what we are delivering to a company is, along the project execution, many different phases, many different deliverables, different kinds and different sorts of detailed models to address different necessities. But finally, when we first start working with engineering, with process engineering team, we later on move all this knowledge gathered along those studies to be in full use of operations with a high fidelity models, with integral models, complete models that allow all the team to perform that other findings, right? So what is important to mention also is that if we put it in a graph, we need to understand that earlier involvement it's critical in instance a facility like an FPSO, because what we have faced when we are involved from the early stages in a process simulation study, in an engineering study, is that at the very beginning of the engineering project time, the capability of impact, the capacity to impact in cost and functionality is very high when you are talking about the early phases of the project. Along the project execution, of course, you do not have, let's say, so wide window, so long window to do modifications. So first insight that you get at the early stages are capable to be done, right? And a minor cost. Along the project execution, the cost of any change that we face by applying simulation studies along the whole project execution, the later we see, the later we get the insight, the more cost it has for the facility. Of course, along the as far as the engineering advance, uh, the, the higher cost of the change and the minor capability to do any changes, of course, because of the purchasing of some critical equipment with long delivery times, etc., etc. So how do we put this, let's say, in a graph, in a kind of flow chart that has more visual about it? How do we plan this in a sort of flow chart? In a flow chart, what we see is that first thing that we do is providing this dynamic model build to perform different kind of engineering studies. Engineering studies that, depending on if we are talking about a greenfield or a brownfield, may be done by using engineering data from the engineering firm. We can do based on plain data if we are talking about the bollering neck of an existing facility, or we can take models from the engineering studies to build a complete model, a complete facility. And what we do is that we perform a first analysis of the critical units to analyze in detail, let's say, different aspects and different behaviors that we need to test, right? So later on, we evolve this detailed model of different packages, and we adjust to add additional equipment, to add the ICSS and the unit control package control narratives and cost-effective matrix and interlocks. If you see, what we are doing is that taking this model that can be built with Aspen HYSYS, with Unisim, depending on your needs, right? And what we are doing later on, once it has been used for engineering study and provide analysis of the critical unit, we add all these details to include later on other buildings, like it's the control narrative and procedure verification. What we are trying to provide to you finally is reusing this model, not only for process engineering studies, but also to start talking and to start iterating and evolving and reusing this information also for operations in the way that we are first testing the control narrative and procedure verification, right? Later on, we will put some details on this. And with the capability to have this model with the different external package logics, sequence implementation, and the main control narratives, what we are able to provide to customers is a first early OTS, an emulated solution where the users will have an emulated graphics, and emulated screens of their ICSS with a high fidelity model, with all the narratives, with all the external packages, logic, and sequence implementation, to start doing a first early CRO training and knowledge transfer without, which is really important at this point, no need at this time to wait for the databases of the ICSS vendor. When we are talking about a greenfield, of course, and we are working in parallel to the ICSS vendor, once they do available the databases of the control logics, once they have been advancing also in their project execution, once they release the first database and the first final screens, we also connect to the dynamic model, and so that allow us to perform two different activities for our customers. One is the PID control tuning. So we are checking and we are testing. We are doing the first ICSS virtual commissioning of all those databases, but instead of facing this for first time during the real facility commissioning, we are performing this against the dynamic model that we have built, and we perform the complete ICSS checkout of all those databases, right? And that allow us to complete what it's called a direct connect OTS, that in parallel to the early OTS, this emulated solution allows to have an early training for the control room operators, panel operators, or field operators, right? But later on, once we complete the checkout, we are in this position to complete the direct connect OTS and provide continuous training, of course, with this tool, with all the logic native logic connected, and provide future maintenance on the other solution. So this is just to put a kind of flowchart that maybe it's more visual, to address the kind of evolution that we are expecting from the models, and the kind of saving also in terms of economics, because you do have the same partner and the same models that are evolving along the project execution, including the necessary detail to address the different insights that we need to take along the different phases of a project like this, right? So it's no need to have this first part with one partner and the OTS with other partner. What we are trying to build, and what we have been able to provide to many customers worldwide, is this complete vision about having a unique, reliable partner to provide all this cycle from engineering studies to OTS completion, to provide the training and continuous training later on, right? So why do say this? It's important to mention that we are talking about high fidelity models that are used from engineering studies till OTS. Think that when we are start talking about high fidelity models, we talk about specific detailed models by using high symmetry, unisim, etc., to create in detail models of the different packages of the complete facility that include all the details regarding thermodynamic, process, all the equipment geometry data, performance, valves, control, instrumentation, data, etc. It's critical for us to explain that when we are building a solution, we are start talking about process design and control validation with engineering team by using this approach, but we move these same high fidelity models and this high fidelity usability to later on be used by operations in their operator training system. So all of the team from process, optimization and control, operations and production take advantage of these first principle models, which is very critical not only to do or to address a good insight in the process side, but also having the realistic experience for operators' point of view. So what provides a solution like this, of course, is that a tool, a test bed that allows safely explore whatever kind of what if scenario without putting people at risk, of course, and providing this training environment, right? So again, it's the kind of technologies that we have mentioned, right? And when we start in unit by unit, what we need, what we finally get, of course, is a full picture about a processing facility that could be, again, an FPSO or whatever kind of installation with many spreadsheets inside. So having an in detail insight about the different, let's say, stages or phases, when we talk about process design and control validation, what does this mean? In instance, if we take a generic PFD of an FPSO, in instance, our main focus when we deliver the first set of studies for a company, when we are asked to deploy engineering studies in first phase, we could be talking about different studies like dry ice formation, if we are talking about the Brazilian region, in the pre-salt region with high CO2 content, in instance. But what we see internationally, no matter if it's in Brazil, if it's in Asia Pacific, if it's in the Western Africa region, is that there is always a need to analyze the critical units. In instance, compressors. We do have works and studies for compressor manufacturers in many sites worldwide, and so we first analyze different studies in the critical sections, like an standalone, to verify the operability and the safety of the plant, right? So at the early stage, all these findings can be handled easy, of course, to achieve the best solution at the minimum design modification and cost, right? So the kind of studies that we perform in specific packages at this time, just some example, is the compression system with a set of scenarios that we are used to provide different verifications on the compression system, on the HP separator, on the seawater and water injection system, right? Most important thing is that showing you how do we are, let's say, a relevant company that provides studies at first stage during pre-feed, feed, and later on EPC to provide all those insights and to analyze different systems, subsystems of the FPSO, like a standalone for process control and design validation. What do we do later on? Once we do have this analysis for different packages, like a standalone, we provide a model integration of the different packages to perform a control narrative verification and early senior zeros. How do is, let's say, drafted? Drafted means that we complete the rest of the top side or the rest of the areas of the FPSO, because what we need to test is not only those specifics that we have start modeling to perform those studies, but when we need to do the control narrative verification, we need to add the rest of the areas and of course the third-party packages integrated with their logics and with these sequences, and that provide the overall this overall model can be used for further testing or to generate additional data for HACCP. With all those models created and linked What we perform is what we provide to you is such kind of deliverable. Is not only the native files, but of course is the kind of reports and the kind of information that we provide to process team and to operations teams, right? To put in clear the insights and what we have seen during all those analyses, right? So we are able to verify all the control narrative specifications in terms of control interactions with the unit control packages. That means how the control narrative behaves when we test and when we connect and we link the different logics that we receive from the different packages that you are handling, right? During normal operation, during non-design conditions, during specific procedures. And so this is the kind of findings that we have, because again, an FPSO is a clear example of, let's say, a puzzle of different vendors, external vendors that provides different packages with different logics and need to perform and to work together, right? So once we do have this control narrative verification, what we do is the operation procedures. Operating procedures, it's another interesting thing, because once we are, let's say, growing the model, what we start testing is not only the control narrative, but now I'm talking to operations, it's all the procedures. How do you draft the procedures and how they are worked when we do have this almost complete dynamic model of the different facility, and we are start interacting with that model, with that high fidelity digital twin, with this control narrative implemented, and to to perform the different procedures that you are expecting. The startup procedure, shutdown procedure, change load procedures, many kind of course, operational procedures that you do have along your operations. And that are the kind of things that we test with such, let's say, platform, right? So what we test, of course, is first all the operational procedures, and later on create this first emulated solution, what we saw during the flow chart, that allows the control room operators, the senior control room operators, has for first time a complete model with an HMI emulated by using the preliminary screens provided by the ICSS vendor to test and to be trained in how are the main procedures that are expected for the facility, like startup, shutdowns, some trip scenarios, some disturbances and malfunctions through digital twin of the FPSO and offline, right? So again, if we follow the flow chart, what it's relevant is that once we do have this capability to having done all the control narrative verification, having done the operational procedure validations against the model, once we can, let's say, lecture the first training by using an emulated solution, it's providing also the added value of a virtual commission of an ICSS by an external company like us. An ICSS checkout means that we can take advantage of that dynamic model that we have already built, that has been enlarged and has been, let's say, growing along the different stages to reach that point. And we use that model, right, to start doing a checkout, right, that we do not need to wait for the finalized DCS database completely. We can do it package by package, because same than we start building the model package by package, ICSS vendors usually used to program their databases package by package, right? So the main figure here is when we have finalized everything, right? But when we do this ICSS checkout, we can start as soon as they advance. We can advance for them to perform that testing, and the level of detail that we get is to validate all the IO signals and transmitter verification, ranges, units, alarm and trip settings, missing and ground connections, all the controllers and logic the implementation according to the latest control philosophy, controllability and operability. We check all the set points, right? All the ranges, block by block. That means that we use the dynamic model as if were the real plant. Why? To test the different blocks, to transmitter, to controller, the controller from the block again, and the output of the model. And what we compare, of course, is all that sequences, right? All the implementation, and what we test is how are we finding this loop against the control narrative that we first validate. If you remember, at the first slide, when we talk about what could go wrong in an instance, an FPSO, one thing is first validate the control narrative, and the other thing is validate the ICSS codification that the ICSS vendor has been done, right? So what we test here is what it has been or is being programmed by the ICSS vendor with such detail. Same that if this was the real plant, we are doing exactly the same by considering the dynamic model, right? And with that information, what we provide is, again, a report, different loops of validation. We used to fix 1, 2, or 3 loops of validation with our customers to provide all those insights and to provide all those reports to the ICSS vendor to correct the different issues that we are facing during the virtual commissioning. Main objective, of course, is us, like a third party, provide to our customers, the much amount of information to correct and to correct all these bugs, not to be faced later on during the real commissioning of the asset facility, right? After that, of course, we are in this position to have complete deployment of an OTS. That means if we are talking about a direct connect, what we do is that we do have the process simulator, all the models created. We have done all the ICSS connectivity, and so we deploy the full architecture with the different operator control stations and instructor stations. If we are talking about an early OTS, the first early OTS, what we first provide is, let's say, a previous version with the exactly same dynamic model, but with all those control narratives inside and with the first emulated screens that we deploy. This is just to show you the difference about what we called early OTS, what we first deploy to allow an early training while ICSS vendor is doing their completion of their databases, and this other architecture is once this is available, once we do have the checkout, so we complete, we finalize the deployment of the OTS, right? So talking about OTSs, from our point of view, from Inprocess point of view, we have deployed right now plus 70 OTS. As you can see, almost 40% in the oil and gas, but of course we perform in the refining, in the petrochemical sector, even fine chemical sector in batch processes, right? So it's a kind of project that we do have in our hands. It's a kind of philosophy that we have implemented worldwide, right? By using, as we mentioned, the main different technologies, process simulation technologies that our customer has in their confidence for the process department, and we extend the use of those technologies not only for the studies, but also to the OTS. Again, what we're trying to do is to avoid doubling investments, one thing for the studies and the other for the OTSs, and relay in one single company with the capability to perform everything and to provide this vision and this insight that comes from the process to operations team, right? And interact with all the different technologies that can be available in the market through our knowledge and through our own technology. But one important thing is that we have been talking about an approach, modeling execution approach. We have been talking about a tool, like an OTS to train operators, but what it's important for a company, it's the training strategy, right? Right now we are talking, we have been talking about performing studies and delivering training tool like an OTS, but what it's later on, what is expected later on. Do you have as company, let's say, a planning about how to train your operators? Inprocess, it can also support companies in providing training strategy for and training materials in addition to exploit that OTS. Having an OTS is having a very powerful tool to train operators and to be used later on by process and by operator engineers to have a complete test bed of your facility, to have an as-built model of your facility, an offline and feature online digital twin of your facility. But one thing is having the tool, and the other thing is how do we implement that training tool in our strategy, right? And how do we consider our instructors lecture different training sessions to our control room operators, right? And in this specific matter, we can also support. We can also support because we are not only, let's say, process simulation users. We are not only OTS developers, but we are also training lecturers, right? And the kind of material that we can implement or we can deploy along such project is very powerful, because usually what we face is that later on, once we have deployed the OTS, the usual instructor from customer point of view used to be a senior operator, right? But the senior operator maybe do not have necessary training material or necessary lecturing skills to be a good trainer for their staff, right? So we also support by delivering and deploying a full set of material as long as we have been engaged from the early stage of the project till the OTS completion, we get a very powerful insight and very high knowledge about the process itself and about the controllability of that process in itself. So we are capable to create specific materials to allow the instructor, the future instructor, having not only a training tool like an OTS, but having a specific training material to focus and to highlight the different values of the training sessions that they are expecting to provide with the OTS, right? That means provide and create different, as you can see here, some examples about what are we are explaining in that scenario, what are we are gonna train, where to focus, which are the critical equipment that you need to look at, which is the first knowledge that maybe a control room operator may have before start training a scenario regarding compressors in an FPSO. Do you have clear what it's an anti-surge controller? Do you have clear how it behaves in your specific compressor that we have modeled in your, let's say, facility or FPSO, right? And all this information can be gathered by us, right? And written in a specific training material and training manuals to support your future instructor in providing not only training sessions, but having the training material to success in this specific task that it's train operators, right? So all these instructor books include different theoretical introduction and process description about the specific process that we have been engaged from the very beginning with your project team, right? So future areas of improvement, of course, we have been talking right now up to this moment, all those offline applications. But in a life cycle modeling, and once your facility is operating, of course, there are other possibilities. Other possibilities means connecting all these models, all these, let's say, finalized OTS, right, to the asset data. Asset data means online connectivity with the real-time database or with some external applications. External applications like AI, ML, or historians like OCPI, like Honeywell PhD, like Aspen IP21, or whatever kind of real-time database, historian or online connectivity with data to feed that models, and so that being able to provide other additional features and additional applications like equipment load and efficiency calculator, bad actor detectors, what if and look ahead. There are many kinds of insights and applications that can be later on deployed once the OTS has been moved. So as a conclusion, right? We have seen many different stages or phases of how we can be involved from the early engagement in a project till the operation and maintenance, right? I'm sorry because I'm doing a little bit fast because I think that we are on time, but I would like to finish with this slide about the summary of the different insights that we have seen along the different slides, and how being early engaged from the very beginning, from the process design and unit control validation till the OTS support to operations, we have been able to have early stage finding for the best solution, for the minimum design modification, and at minimum cost, right? So we have been able to detect the missing equipments and unreachable interlocks conditions. Operators have more availability about this facility. Operators gain confidence and awareness about the plant behavior and iterators and interactions, sorry. And the final product, it's a tool that can be used for training purposes, of course, but also as a basis for further control logic modifications, optimizations, control tuning, support operations in unfrozen condition or configurations, right? So most important thing for us is, again, having for you the vision that rely on a unique partner, reliable partner that has the expertise and the relevant track record to support from engineering studies to operation and maintenance support, and having delivered the OTS insight, it's a definitely cost-effective solution in terms of project execution, in terms of the different deliverables that you are asking for usually in many projects, and the only way to retain and to keep the knowledge that we get from process to operations with one single partner, right? And okay, different examples of this can be taken on on our participation on different public articles and Congress contributions with the different case studies that we have successfully performed worldwide. So from my point of view, thank you very much. I'm sorry because I don't know if has been any question during the exposition on the log, but you know that when you are in the presentation mode, I cannot see the different questions that may arise, or if you have any, please feel free to ask, and Avinash may do the moderator.
Sure. Thank you so much, Danny, for the wonderful presentation. I think you have made an excellent point on how we actually progress from each phase, from process design verification to model integration and control narrative verification, procedure verifications, then emulated OTS, ICSS checkout, and finally an OTS. I think you've made a very good point. It was a wonderful presentation. I enjoyed it a lot. And I personally love the graph that you showed, whereby when we progress from stage to stage, the cost impact then goes up. I think that's just the whole point of telling them why the life cycle modeling is so important. I love that graph, Danny. Good job.
Okay.
Okay.
Thank you.
We have a couple of questions. Actually, two questions here from Stuart. Are you ready to take them, Danny?
Yeah.
Okay. The first question from him is that does following this workflow have any impact on the schedule, as data is often delayed? So the second part of that question is, will you require the full detailed information, or can we start with, let's say, 80% of the information in hand? So what kind of information do we need to actually start this?
No, in fact, thank you very much, Stuart, because it's a good question, and think that this workflow, I mean, we do not impact on the schedule. It's just the opposite. I mean, we try to adapt our job to the schedule of a fast track project that usually we face, and in fact, we are conscient and we are aware that usually not all the information is available from the very beginning. And let me come back very quick to slide 6 that I showed to you before. In that slide, what we of course know and are aware is that depending on the phase that we are, depending on if we are at this early stage, like a conceptual design, or later on a pre-feed, feed, and later on the detailed EPC, of course, we are supporting many companies along this. Sorry, let me have this in presentation mode. We are able to, and we are used to work with the EPCs, engineering companies, and operating companies that along this project, of course, we are provided more data, right? So what it's true is that the kind of insights that we can provide to you as long as the information is available. So, of course, the more information you have, the better. But one important thing is to start having the first ideas and the first insights about what is the correct design or not. When we are supporting conceptual, if we are supporting conceptual, even with a steady state simulation, but most of the cases with some transients to analyze the best suitable design, of course, we assume that not much of the information is still available at this early phase. So the question is that definitely no, we don't need to have all the information available complete. One of the things, of course, is that for doing all those insights, we are assuming that every time we will be provided more information, but as it's mentioned here, what we will do is including more details to the models along the different information is availability, and this information is a very wide concept. That means from conceptual design, again, to have a complete detail about the control narrative, right, and the ICSS information. But of course, what we are doing is not let's say not interrupt the project schedule. On the other side, what we do is try to speed up the decisions to be made according to the test that and the different simulations that we are able to provide to support our customers having the most correct decisions about the design, process, and control design by using a test bed like the dynamic simulation uses, right? So definitely not. And in many cases, we have start supporting with maybe just 60% of engineering complete, and you are start guessing about different designing conditions, designing sizings, designing criteria, right? And this is the kind of studies that we first do. Dynamic simulation studies to verify this design and this process analysis, where the engineering is still not complete, and maybe we are talking again about maybe 60–70% of engineering advance.
I hope that answers to its question. So what we actually do with the life cycle modeling in summary is that we adapt it according to whatever data that we have, and we build a sustainable model where we actually add on information as we go along the engineering life cycle. Correct, Danny?
Right.
Okay, perfect. I think Leo has his hands up. Leo, you want to add anything, or do you have a question?
Yes, I'd like to add more information about Danny. I'm also working from Inprocess. And what I'd like to say is that basically the phases that we have in the life cycle approach are basically aligned with the project, with the plant life cycle, right? When you mention, like, for example, if we can start with early data, this can basically be applied at any phase or at any stage of the process, right? Take into account that, for example, when we start the feed, for example, and we start evaluating an early control, At this point, in reality, we don't have all the detailed data because this is going to be at a later stage, right? But even though at this point, when we have a very early data and configuration of the plant, we can in any case make an analysis to understand if the control from the conceptual point is going to work or not. With this dynamic simulation partially done with early data, at the end, we are going to be retuning the model during all the stages of the project. Now, for example, if now we're trying to focus on a DCS virtual commissioning phase, for example, at this point, we don't need to start when the ICSS has already passed the FAT, because at this point, we would be already late for an operator training simulator. Okay, so what do we normally do? We start making the DCS virtual commissioning phase when we have the ICSS maybe at 50%. And with this 50%, we start analyzing how is the ICSS. We start making the connections between the model and the ICSS, and then we start getting findings. With these findings, we provided as feedback to the clients so they can basically make the update of the ICSS. But this implies that we're going to make, like, for example, 3 or 4 revisions of the ICSS database, right? So, and this allows us at the end that when we want to make the OTS startup, we have already made so many verifications in the early phase that we have much more time in order to finalize it and be able to start training, right? So at the end, this life cycle is basically thought to be aligned with all the plant life cycle activities, right? From the conceptual design to the feed to the detail engineering, commissioning, startup, and maintenance. In all these points, you're always going to be missing information, and it's not going to be final. But at this point, we are able to provide help in order that you have the most important critical decision, right? Mm-hmm. So you can make your best decisions.
Yep. Yeah. Thank you, Leo. Mm-hmm.
Thank you for adding that on, Leo. Danny, the second question is also from Stuart. His question is, how long is the computational time for a fully integrated model? And the second part of the question, are there methods to speed it up, such as tubular thermodynamic data?
Yeah, how long? It's a good question because you mentioned how long is the computational time for a fully integrated model? Okay, the first thing is that when we talk about computational time, think that we are talking about a modeling a facility, right? So depending, sometimes we have been talking today, we have been taking as an example an FPSO, right? And so what are we interested in to address with that computational time for fully integrated model? I mean, have we previously spent some time in modeling and to perform a specific dynamic simulation analysis for some critical packages, or we are starting to create an integrated model of a facility? As an average, let's say that when we are talking about an FPSO, maybe we are taking about 4 months, between 4 or 5 months to get the complete dynamic model of the whole topside facility. If we are talking, I mean, building the topside model and having the interaction with the subsea behavior, right? For the HP separator and test separators. If we are talking about an FPSO, right? So maybe it takes 4 or 5 months to have a complete integrated model of a facility. But we adapt, of course, depending on customer needs. This integrated model will compile all the information regarding process. When I mean process, is all the thermodynamic packages that are available in softwares like HYSYS, like Unisim, like Symmetry, in instance, that has a contrast thermodynamics for all the oil and gas processes. Same if we are talking about a refinery, or same if we are talking about a petrochem, where we use also the most adequate thermo package available in such kind of technologies like Aspen suite, Honeywell suite, or any other suite, right? And how to speed up like tabula thermodynamica data, it's not a matter of speed up. What I understand is that depending on the process we are addressing, if we are talking about an FPSO, fortunately, all the processes or that we can face in an FPSO should be correctly modeled by using such modeling technologies. I mean, all the thermal packages are already included. Maybe we are using, in fact, some external spreadsheets or some external tabular thermodynamics to represent the correct behavior of something that it's not already included in high Caesar unisym. I mean, if we are talking about a turbo expander, if we are talking about carryover, if we are talking about the membranes of the CO2 membranes. Of course, this is information that maybe is not available in this commercial software, and the use of this tabular thermodynamic maybe is not a question of a speed up, but if it's a question of how to correctly represent different thermal properties that are not correctly or at all available at those softwares, right? But the point is that having those models may take that time. And what we use is such kind of a spreadsheet or tabular thermodynamic specific to correctly represent those processes or those units that are not available in softwares like the ones that we are talking. Yeah, maybe Leo maybe can add some detail on that.
Yep.
Yes, I've seen that the comment from Stuart is basically for the computational time. Yep. This is basically the simulation time, right? So what we can do is basically, there are two things, right? One is how we build basically the dynamic models, right? There is always room for optimization and to be able to reach the real time or even higher simulation times, right? But this basically, there are several tricks that you can take into account once you build a dynamic model, right? The other point is basically how big is the plant, right? If this is a massive plant, maybe just with one model it isn't sufficient. And then in this case, you need to split up the dynamic model, for example, in two. And then you need to understand very well at what point is the more efficient place to cut the dynamic model in order to improve the computational time without breaking many interactions within the systems, right? These are the two main points, right? In our cases, for example, when we are targeting like massive plants, in some cases we need to split. Instead of using one dynamic model, then we have to use maybe two dynamic models, right? And then we make the integration between these two dynamic models using our own software that is the Inprocess infrastructure suite, right? So we have the capability to connect into models. In this case, you have a much higher simulation time because you're splitting the work, right?
Yeah, thank you, Leo, because I'm sorry, because I understood the question regarding about the, you know, the execution itself, the timing for execution. But yeah, it's what Leo is mentioning. Of course, if we are talking about studies, engineering studies, computational time, it's not an issue, because you can let the model run for different time, you know, to find finally what you are trying to address with this specific in detail model for some specific study. But the other thing is the computational time, of course, when you are talking about a training tool and where you are in front of an OTS, because it's the kind of feeling that the operator has of their plant. So at minimum, of course, we need to guarantee that can be run at real-time factor. This is the minimum. But of course, in all the OTSs, we are asked not to match the real-time factor, but of course, to be able to run more in addition to the real-time factor. And it's what Leo is explaining right now. Depending on the size of the model, depending on the complexities of the model, it's something that we do internally, but we split the dynamic model just to always assure that we can be at the necessary velocity, not only to be at least at real-time factor 1, but of course to go faster for for the correct experience for training point of view.
Thank you for the responses, Danny and Leo. I think it's pretty clear now on where we stand in terms of computational time or simulation time. So I don't have any more questions coming in from the audience. I'd like to open the floor. If any of you have any questions, feel free to unmute yourself and ask Danny while it's here. Still see a few of them tuned in. Or if you're shy, you can always drop the questions in the chat space. I can read them out to Danny as well. Feel free to do whichever you like. Okay, if we don't got any more questions in the next couple of minutes, I think we can call it a day. It's been 5:20. We had 20 minutes off schedule, but I think it was a wonderful presentation by Danny, and there was a lot of interesting questions that we usually get from hardcore modelers. I think Stuart is definitely a process simulation expert here who has been using it for years with all the questions that he has. Probably give another 2 minutes for the attendees to brainstorm. If there are no questions, Danny, I think we can call it a day for today. While all of you are here, yeah, I see someone unmuting themselves. Swine, hi. Good evening. Okay, I think that was an accident. So Danny, since there are no more questions coming in from the attendees, I think we'll call this the end of the session. I'd like to thank you for taking your time for joining us and giving us this wonderful insight and presentation. And I'd like to thank all the attendees for taking your time this evening to join us in this webinar. So we'll be planning a few more sessions towards the end of this year, probably next month or so. So please do follow us on LinkedIn as well as our webpage. You always can stay tuned to find out our next webinars. So with that, thank you, Danny, thank you all the attendees. We hope to see you in our next webinar.
Yeah, thank you, Avinash. Thank you, Is101, for the opportunity to participate in this interesting webinar, and thank you all of you, all the audience, to attend this webinar. Thank you very much.
Thank you, Danny. Thank you, everyone. Take care. Stay safe. Goodbye.
Thank you. Take care. Bye bye.